Hello and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of writing systems of equations. This is standard A.2I in the great state of Texas, and we are using item number 48 of the 2016 released STAAR test. If you haven't done so already, please take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we have a bag that's got 18 coins. We've got quarters and dimes. Total value of the coins is 285. All right. Which equation can be used to find the number of quarters and dimes? All right. So this is a really short problem, but they give us quite a bit of information. Now we do have to supply the value of the quarters and the dimes, right? So they don't tell us this, but they're inferring that we know quarters are worth 25 cents. Dimes are worth 10 cents. All right, so what do we know about this system of equations? Because what they're wanting us to do is find, as you see in our answer selections here, two different linear equations that if we were to graph them would have a solution. Right, so if, let's say we graphed them and they kind of look like this, wherever they would cross that intersection right there would be a solution for both. And so let's just look at this very first sentence right here. A bag contains 18 coins consisting of quarters and dimes. We don't know how many quarters, we don't know how many dimes, but we do know that if we add the number of quarters and we add the number of dimes, we're going to get 18. That's what that first sentence says. We're not dealing with the value yet. That's coming in the next sentence. But it's as simple as quarters and dimes equal 18. There's an 18 coins, just quarters and dimes. So you see we have that in all three of our answers, F, G, and H. In J, they kind of mix it up. They give us that 285. That's the value of the coins. That's not the number of the coins. So a system of equations is at least two linear equations that use the same variables here, Q and D. So that's how you can solve them. All right, so Q plus D equals 18. Let's get into this next one. The total value of the coins is, so that is going to be our equal sign, is what? What's the total value? 285. All right, so something is 285. Total value of the coins, we don't know how many quarters, we don't know how many nickels, but look, now we're dealing with dollars and cents. That's what that 285 is, the $2.85. And that's where all of this is going to come into effect, 25 cents and 10 cents. Now, we're dropping the dollar sign, right? But if we want, we can, just for clarity's sake, we can add that. Because if we're dealing with $2.85, we need to be dealing with dollars and cents in our quarters. So how much is each quarter worth? Well, each quarter is worth 25 cents. So 25 cents multiplied by the amount of quarters we have. We still don't know how many quarters we have. It's somewhere between 0 and 18, right? But if we multiply each of those quarters by 25 cents, and then we multiplied each of those dimes by 10 cents, because dimes are worth 10 cents, we added up those values, we would get $2.85. So that's what we're getting from that second sentence. And obviously they just wrote it a little bit cleaner. So we'll just kind of bring it down here, drop the dollar signs, 0.25Q, 25 cents per quarter, plus 0.10D, 10 cents per dime, equals 2.85 or $2.85. Right? And so where do we see this one? Right, we see that on H. Look at G and F. They've got 10 cents per quarter. It's 25 cents per quarter. So that's the issue there. Now, if we wanted to solve it, right, we could solve this by, let's just kind of rewrite this. Q equals, let's make that a Q, right? 18 minus D, right? I just took the D to the other side, and then substitute this in to here, and we could actually solve for the system. But our answer here is H.